In this question, they ask, which statement is always true? And when you encounter a question like this, they're asking you to test out the statements they give you for every possible case that you can think of. So this is not something, well, you might know this, but this is not something you have to know or memorize. So don't be scared when you see this and think, I don't know this. Instead, do a little experimentation. Test out what they're saying here and find out for yourself if it makes sense. And that's often what we do in mathematics. We don't memorize a bunch of stuff. Instead, we see if we can reason our way through each idea. So what does the first one say? It says an even number times 2 equals an even number. So for example, let's say I take some even numbers, and this is where you start to experiment. 2 is an even number, and 2 times 2 gives me 4. Okay, so 4 is another even number, so that seems to work. Let's try another number. I can't try 3 because I'm only looking at even numbers. So let's try the next even number I want to plug in, which is 4. And 4 times 2 is 8. So it produces another number. And I suggest trying one more. Let's try 6. 6 times 2 is 12. So it seems, this is not really a proof, but it seems that this is actually true. Let's try to disprove some of the other ones to see if this is the only choice that makes sense. So A seems like a possibility. B says that an odd number times 2 is an odd number. Let's try an experiment with that. I'm going to plug in 1. There's an odd number. 1 times 2. Well, that's 2. So I took an odd number, I multiplied it by 2, and what I got was an even number. So this is not true, right? An odd number times 2 doesn't give you an odd number, it gives you an even number. As soon as you find one example that is the opposite of what they say here, you've shown it's not always true, right? You found one case where it's not true. In C it says an even number times 3 is an odd number. So let's try that one. So 2 is an even number times 3. Well, that gives me 6. And 6 is even, not odd. So this is not true. And lastly, we have D. D says an odd number times 3 is an even number. So I'll start with an odd number like 3 times 3. And what do I get? Well, then I get an odd number. So this is not always true. So it seems that my answer is A, and let's just take a moment to talk about why that might make sense. Why isn't an even number times 2 an even number? Why is that always true? Well, let's think about what an even number really is. What is an even number? Well, we can write a list out like 0 is even, and 2, 4, 6, 8, and so forth. When we look at even numbers, we should look at the factors. Factors are numbers, right, that multiply to equal out what your multiple or whatever you're looking for. So factors of 0. I can say 2 is a factor of 0 because 2 times 0 is 0. Okay, what about 2? Well, 2 is also a factor of 2 because 2 times 1 is 2. And 4, well, 2 is a factor of 4 because 2 times 2 is 4. And this keeps going, right? You notice here that 2 is always a factor of an even number. For example, 6. Well, 2 times 3 is 6. And for 8, 2 times 4 is 8. In fact, what an even number really is a number that's a multiple of 2. That's the definition of it. So if you take a number, right, like an even number or an odd number, and you multiply it by 2, so an even times 2, you're creating a new number, right, that is a multiple of 2. In other words, a number that's an even number, right? Because whatever number I start with, once I multiply it by 2, the number I create, right, has to be something times 2. That's what the definition of a multiple of 2 is. So of course we're going to get an even number. And I hope I'm saying that in a way that makes sense because this idea is essential. All right, I hope this helped.